Welcome everyone, and thank you for joining the Trackunit Fork. This is the second event we have here in coding. Last time we did a presentation of our front-end architecture. This time we go a level deeper and talk about the GraphQL layer. But first off, I want to tell you what the Trackunit Fork is all about. It's an initiative to share what we have of interest to the world, and we hope that you'll chip in on this journey. Like last time to this time, we've actually asked everyone to chip in if they had something that they felt was interesting to just share to the rest of us. And we'll do the same next time, and no worries, we'll keep adding to the agenda until it's packed. This time around, it's all about GraphQL, extending again, we're focused on this extendable platform, and in that we are building the public GraphQL layer. And it's that journey that we're on we want to present today. So the agenda for today is I'll talk briefly about what Trackunit is and this Iris SDK journey we're on. Then we'll have a topic about the journey to GraphQL. Then there'll be a talk about why GraphQL is important for the front end. Then we'll talk about the federated supergraphs using schema stitching. And then there will be a workshop where you get to open up the laptop and actually write some code where we're stitching together a couple of graphs. And then we'll wrap up talking about code generators and directives and why they are important, maybe even share a little bit about our public GraphQL journey that we are on. And yeah, networking afterwards. Trackunit has a long history. And if we look back just 10 years ago, we're actually not focused on the construction industry. But the last 10 years, it's been really focused on the construction industry and making sure that everything for construction is set up for success. So we have these small SIM cards embedded in the machines, meaning that all data can be transferred to the cloud. And then we have a ton of data coming in, 1 million connected devices right now. And when we look at the potential, there's 100 million. From the tier 1, which is the big machines out in the construction field, down to the smaller things like a driller or an attachment to one of these big machines. If they want to track that, it's a Bluetooth tag like what Apple has with their Apple tag. So knowing where everything is, so they know if something gets stolen, if they can track it in our platform, that's the journey. And right now, we're actually in the process of building an SDK where people can contribute into our front-end application called the Manager. So this UI application we want external developers to be able to contribute to that. We want the OEMs to be able to build their own machine homepage instead of building that. Wagoneisen builds it on their own and Caterpillar does it on their own. That's just not feasible going forward. The one dealing with the software the one using the software should be able to just have one platform and get all the data in there. And the trend is actually interesting because there's a lot of trend on CO2 emission for a job site or a working platform. And if we look at that as a whole, not one company can solve that except if we chip into this platform. So there is already a big push from governments to say, hey, you need to be able to tell us how much CO2 is being promoted or generated by your job sites. So interesting things for us as a construction industry. And with that, I will hand it over to Mads.
Yes, so I'm going to talk a bit about why GraphQL is important and why we're even investing time in Go. Why do we need GraphQL? The most simple setup I can imagine would be you have a web app and you have some backend. It's just one monolith. It has an API, you can call it. Everything's simple. But at some point, you're probably gonna want to introduce different microservices. Then you might have a book service and an author service, and your web app will then be responsible for calling these two services. That might be okay in the beginning, but as the number of services grows, then the pain on the front end grows even further. A common pattern is to build a backend for front end, a BFF, because then the web app will just have one service to call, and it can call that service, and that service can handle all this, and all these calls can happen on a local network that's fast, instead of over the internet that might be on the other side of the globe. That works okay for some time, and then you start adding more clients. Maybe you try to use the same BFF probably fails because the requirements of the web app are not the same as the requirements of the mobile app. And then you split it out, you end up having a BFF for the web app and a BFF for the phone app. Again, as time goes by, you probably, maybe you have an internal tool that you also need to connect, that you have all kinds of different clients. So you end up with a lot of backends for frontends, and they all need to be maintained. And whenever somebody from the book service needs to add a new feature, they need to go to each and every single BFF and make sure that their feature is supported in all the places. This is where GraphQL comes in. GraphQL is a way to represent data as a graph and then do queries on that graph. The idea with GraphQL, and what's the recommended best practice, is that you have one graph as like the company graph that all clients will use, and then that GraphQL server can then delegate to all the different microservices and actually do all the hard lifting of, okay, how do I get this data for this client? As I said, everything is a graph. So you have a book will have a relationship to an author might have a relationship to another author because they're co-authors. And they're gonna have some simple labels on them as well. And in GraphQL, you represent this as using this schema definition language. By default, you have a type called query, and that's your entry point into the graph. In this example, there is one query called book. It takes an ISBN number and returns a type book. If you look at the type book, it has a title and it has a list of authors. GraphQL has this slightly strange way of showing arrays where you put the square brackets around and not in the end. But finally, you have an author that will have a name and some co-authors. That's basically the same representation as this graph, just in an ASCII format instead of having it graphical. The unique thing about GraphQL is that the client always tells what data they need. If you have a frontend that only needs a little bit of data, you can do a very efficient query and ask for just exactly that data the frontend needs. In this example, we are doing a query using the book query, asking for the title and the authors, and on each author, we are asked for the name. And then we get this result set back that says, okay, it's the best book written by 2 Trackunit developers. One thing to keep in mind in GraphQL is that we want to avoid tree graphs. It's very easy to have okay, now we're doing GraphQL, then you just add a ton of queries that will get all the data you need. That's nice and all, but you don't really get the benefit. The client still needs to do a query to get some data and then another query to get some other data. So with GraphQL, the recommended pattern is to make sure data is linked together. So in this example, you might have a root query that will give you the author and another root query that gives you the book. But from there on, you can traverse the graph to get exactly the data you need. That makes sure that it's very extensible and open, because as we are building an extendable platform where other developers will be calling our GraphQL, we don't know exactly what queries they're going to need. So in this case, we'll break down, because we might have a specific query to get the publisher, but maybe the query params didn't match what some external developer wants. An example of this is if you're adding an address to this schema, you might be inclined to just add it at the root queries. Hey, just give me the author address, because right here in this use case, I just need the author address. But a better way to add it is to add it on the author, so such that it gets linked together. Because then if I need to get the books and the city where the author of that book lives, then I can do a query for that data as well. In this case, I can only give the name as parameter. I cannot give the ISBN number. So in this case, I end up with very rigid querying capability, whereas in this case, I can do whatever I want. So, Kasper.
Yes. So why is GraphQL important, or at least nice to have in front ends? Go to some code. So I made a small code example where I can get this to show video panel, hide floating media controls. Okay. I want to do the API for Star Wars. There is a public API for that. They also have a GraphQL version. And I want to have this front-end app where I can show by movie which starships are there and who is the pilot and which planet do they come from, what species are they. So then I implement that in REST here in a very ugly code, but basically I go get all of the films first up here, and then afterwards I map into the films and say, okay, so for the films I need all of the ships, so I'll map over that and then I'll do a promise all on that. And then from there I will go into the ships and get the pilots, and then I'll do again a promise all to get all of the pilots. And for each of the pilots I'll do a promise all to get all of the species. And then I gave up at that point, but I could also get the world and whatever I wanted to get from that point of. So that's a bunch of queries or a bunch of fetch calls that I need to do just to do this small UI, maybe with cards that just shows the movie and the pilots and their species. Then we have the GraphQL version. Up here I defined my query as a string. And then the GraphQL is not magic. It's pretty simple. It's just a post request. So I just use fetch set its post, and in the body I have a query parameter that is my query. That's all I need for this very basic example. If you have variables in your query, so you need to do filtering or ask for a specific film or something, you add instead of a query, you add just a variables object. Your variables are defined. Yeah, so pretty simple. And then let's look at the benefit of it. Now I have a really nice front end. Do a reload, see if it works. First I'll load the rest, and then I'll load from GraphQL. We already got a response. And now we are waiting. And we are waiting. And I hope it goes through. I have had issues where it doesn't go through. Now it's there. So no issues along the way, but it took way longer, and the data that we get out is 100,000 extra characters than what we get out in the GraphQL. So that is what I need. This is what I get for my query in the REST version. So we scroll down here at some point, it just disappears. On the other side, then we have way too much code. So it's just to say, as a front-end developer or whoever it is using all of these microservices, it's so much easier if you have a GraphQL with a graph that is nicely put together, because then you can just go in and say, hey, I actually need all of this data. And soon we will also show how you can traverse this so you don't need to know the graph. You can just click and then you get these queries, or maybe even a React hook or another easy thing. And this example was it's just a fetch request. It's just a post to a server. You can get a bunch of tooling that helps you out. One of the things that is a bit annoying about GraphQL, in the beginning at least, if you just do it like this, is that the GraphQL will always return a 200 unless an actual server error occurs. So if there's something in the GraphQL that goes wrong for some reason, it'll still a 200 and then it'll have an error. So all is good, here's the error. Basically because the idea is you can do partial errors. So therefore it's easier if you select a tool that can handle stuff like that for you and say, ooh, there was an error, and do some schema validation and stuff like that. I think, yeah, that's it for me. Why we like it in the front end.
Yes. So hopefully it makes sense why we're looking at GraphQL. But there's one issue. And now we have this GraphQL server in the middle. And essentially we just create a new monolith. Whenever the book service needs to change something, it needs to go to the GraphQL server, update the schema, make sure it maps the right data, and I just need to kill this phone. So we didn't really gain a lot when we look at like the release cycle speed and making sure the book service team can release independently and so on. But there's an answer to that. And at least one idea is to, instead of saying that only this one in the middle knows the graph, we'll push out the graph, essentially cut up the graph in smaller pieces, such that there will be a book subgraph, an author subgraph, publisher subgraph that only deals with each domain. And then there will be a GraphQL router that's responsible for taking all these subgraphs and then stitching it all together to form one supergraph that contains all the individual subgraphs. And just to get back to my book author example, one way to split up this graph would be to say, now there is book subgraph. It's very simple. It has one book query and it has a book type with some properties on it. There's nothing about the author of the book because that is in the author domain. It will just have information about the book. That will be super simple to implement. Then in the author service, we can implement this subgraph. It's slightly more complex because we need an extra query to stitch in the data. Here in the top we have this stitch book query, takes a book ID and returns a book type. In this subgraph, the book is a very simple object. It contains the ID and then the authors of that book. It doesn't have any idea about the title or of the page count of the book, just the authors, because we are in the author subgraph. And then of course there's the author and the address, and that's all the same like before. What happens then with the schema stitching is, or actually more specifically type merging, is that the GraphQL router will take these two different types, because they're called the same name. It will then merge them together to form one type that has all the different properties from both subgraphs. That means that different subgraphs, they can contribute data to shared entities that they might know something about. So in this case, the author service knows about that which authors were on a book, but doesn't know anything more about the book. When we then need to execute a query, so in this example, it's the same query as before. You are requesting a book with an ISBN number, you want the title, and you want the name of the authors. What the GraphQL router will do is first see, it's referring to the book query. So it needs to, the book query is owned by the book subgraph. So it'll send that query on to the book subgraph, but of course the book subgraph doesn't know anything about authors. So it'll just request the ID and the title. And the book subgraph happily replies, this is the best book, ID 42. Now the GraphQL router knows the ID of the book, because if you remember a few slides back, the author service didn't have anything about ISBN numbers, it just had some internal ID. So it'll take the query and the new data it just got from the book subgraph, and then it will form a query for the author subgraph that using this ID, and then whatever fields was requested in the query that is owned by the author subgraph. Then it replies, here are the authors, and now the router will have these two pieces of data. It will have this from the book subgraph and this from the author subgraph, and then it's just a simple merging that data together and returning it to the client. And that is in essence what schema stitching is about. There are a lot of optimization, of course. In this example, it needed to wait for the results from the book service before it could call the author service. If they share the same ID, it can do those things in parallel. But I wanted a little more interesting example. And you can even do it like multiple layers. If the author had, I don't know, a favorite restaurant, you could have a different restaurant service stitch in that. It gives a ton of benefits. The biggest benefit, at least for me, is that now these different subgraphs can actually release more independently, because they don't need to coordinate on, okay, who can we just update this and now there's a bug and can we not? It's still possible to contribute data between the subgraphs. So you can still say that, hey, if the publisher knows a little bit about the book, he can contribute and stitch that data in on the book type. So from the user or front-end developer point of view, it's still a coherent graph, but on the backend side, you can start separating up a responsibility between teams. Yes, just a little bit of naming, because this area with Supergraphs is not completely standardized. There was an old schema stitching project run by Apollo primarily. It had a number of issues, and Apollo ended up abandoning it. And then Apollo created Apollo Federation, which is, now what I showed now was more or less schema stitching, but Apollo Federation is very similar. It's the same idea, you have different subgraphs and you merge them together. Apollo Federation is an Apollo technology. The basic bits are open source and you can run them without having a license with Apollo, but if all the more enterprisey things are paid features. And it's the Apollo project. That was just GraphQL Summit in November. They announced new features for Apollo Federation, and it's all Apollo all the way. Then on the side, a company called The Guild actually picked up this schema stitching when Apollo abandoned it. And they added this type merging and they had something called directive-based stitching. I'll come back to that later. But we are using this one. First of all, it's super flexible, where Apollo Federation requires you to be on a certain version of GraphQL and different libraries. This one supports basically anything. And for us, it was a very simple migration path because we already had I think 70, you've counted this morning, 70 different subgraphs. So it was easy for us to pick it up because it was so flexible. And then it also has the possibility to co-host the router and the subgraph in one process. And basically where we're coming from, we had that monolith GraphQL server and felt the pain of it. And what we then did was simply separate the code out in different subgraphs, but then have it still deploy in one process. And what we're doing now is then we're pulling it out and to the individual services that actually owns the subgraph. And finally, the Guild is super nice companies to work with. We try to hire them and to help us with this. And the response was that, we don't want money, but we can set up a Slack channel and we can just ask questions. And we don't have a SLA with them, but they usually reply within a day. Anyway, that's really nice. Apollo, on the other hand, they send some very big number to us, and they are very much moving in the enterprise direction. But I think the interesting thing about Apollo Federation is that they have this effective router implemented in Rust, and only focusing on the routing bits, whereas this one is based on Node.js. So it's not as performant. Maybe we'll hit a point at some point where we need to look at Apollo Federation. Yes. Now it's time for a short break, and then we'll questions. Florian?
When you write a query in the front end, how do you make sure that now the backend changes, and how you make sure that it doesn't break the front end? Because I don't know, do you have any kind of? I have no idea.
Yeah, we have a tool that detects breaking changes. I don't know, Mikkel, can you talk to that? Oh.
Yeah. So we have our own danger bot that's checking if there's any breaking changes. So on the pull request, we can tell if there's any breaking changes on the backend side. So basically letting developers know that, hey, this is actually a breaking change in the GraphQL layer. That's one thing. The other thing is we have a NX repo where we have everything combined. So we can change the front end and the back end at the same time. And we know for sure that it works because we're actually generating the front end queries against that schema that we have. So we know for sure that when we hit master, it actually works. But we can only do that for our own stuff. We can't do that when we start making public GraphQL available for external developers. So that's why it's important that we get notified that, okay, this is a breaking change. We have a GraphQL version that's running for our internal software, but also another one for the public. If the public changes, then it's a big one. We can't do that. But we'll show you a little bit later that you can actually make breaking changes.
Yeah, there are some tools to help with managing the lifecycle of, and we'll come back to that.
The danger bot is basically just reads the old schema and the new schema, and then it checks, hey, is there any diffs here that I find breaking due to something being required, or stuff that was not nullable now is nullable, or whatever you added, or something was removed. So it's pretty simple, the danger part of it, to let developers know. And then it's on them internally to make sure that I actually run the front end, find out where these queries are used, and then test that it still works. Or go to the front end developer, say, hey, I broke this query, could you please fix it before I merge to master?
That's also another point. When we do public GraphQL, it's so important that you do it right the first time. If you do a REST API, you can always do a version 2 and 3 and 4. But when you do GraphQL, it's really hard to change. You can read posts online talking about if you have something exposing an image, maybe you call it an image now, but maybe you want that image to be a URL later. So you really want to make sure that you return it nullable, meaning that whoever reads it needs to understand that at some point maybe it's null. That forces the user of that API to say, all right, what if it's null? What should I return instead? Should I show no image or whatever? So it doesn't break the front end. And then you can say, now I'm deprecating this field, and since it's nullable, it's safe to return null. And then you can introduce a new field and say, now we've moved from A to B. That's why when you look at public GraphQLs, a lot of the data is actually nullable. That's just to be on the safe side. Then they can do a refactor later on. So it is very different talking about GraphQL than REST APIs when it comes to versioning. There's no one talking about versioning with version 2 or 3 or 4. It's just the graph is then evolving. It's deprecating certain fields and introducing new fields. The good thing about the schema stitching is you can actually say this is my legacy service providing some legacy URL in case someone is asking for it. And then you can build a new shiny thing in a separate subgraph, right? So you can actually say, yeah, we know we have this and we have to maintain it, but at least it's not in our face all the time. But it's still part of the GraphQL.
You could expose another GraphQL service called V2 and say, now I have a V2. But that's just not what is recommended, and that's bad practice. And yeah. But again, it's just a fetch call. You can do whatever you want.
Any other questions? Yeah?
I guess it's a design decision of the application, but can you end up in a situation where these microservices in the backend know about each other and would need to call each other? I guess it's how you design it, and if you design it so they don't know about each other.
To me, when you do the stitching right, you don't have to do that. I think you'll see it when we have the coding challenge later today. You'll see that we can actually pick and choose from 2 separate graphs and combine it to our own, and the one consuming it doesn't know anything about that. And that to me proves that we can have certain microservices just understand their own part of it, the schema. With the type merging, for instance, the book example you came with, there you have the author also supplies a book entity, but it's only the ID and then the author. All the other properties, they come from somewhere else. And that's the beauty of it. You don't have to split out the entire model, but of course you need the identity of the entity.
Oh, I think the recording stopped. But yeah, the book example is actually a good example because you're calling the book service to get from the ISBN number to the ID, and then the author service just knows by IDs. It doesn't need to call the book service. You could have another call that says, okay, I have the ISBN number, so I call the author service with the ISBN number, and then the author service calls the book service to get the ID based on the ISBN number. But
I guess that was also why I said you might be able to design around it, but I can't quite wrap my head around all these scenarios. Clearly, I can see.
It also takes some time to wrap your head around it, and sometimes you're like, oh, we cannot solve this, and then you think about it for a while, and oh, there's actually a way to do the stitching, so you don't need to have that interdependencies between the services.
But we hear a lot from our customers using the REST API that, hey, I want this domain, but I also want this domain, and I don't want to call you guys twice. And in that case, we would just say, hey, you have to go to our GraphQL layer instead. If you want that flexibility, then that's what you need to do, so that you can design the REST APIs to just talking about a microservice and exposing that. But it requires some discipline. Yeah, other questions? Yeah?
Can we set boundaries or rules saying these subgraphs cannot be stitched together? Because is there a case where some entities should be fetched from a particular subgraph for some reason? Maybe it's available in 2 subgraphs. Is that possible? And then you want to say this value should come from this subgraph.
It is possible to expose the same data from multiple microservices. We actually have that in certain places where we have an Elasticsearch on the backend doing a lot of searching. And if you search for something, it might actually have the data, so you don't need to call another microservice. In that case, we are returning the same field. In that case, there's some coordination because you have a field called X on microservice X, and it should also be called X on another microservice. And there is a way to say that this one is the authority true one. We haven't used that. We've just taken whoever has the data and then trust that our Kafka queues and stuff behind make sure that the data is in sync. But you can mark one field as the truth. But you simply do it because you want performance. You don't want to have another lookup in database if you already have the data.
Is there like a certain scale that you actually feel like you need GraphQL, or you can use GraphQL for like simple, I don't know, your customers, number of customers, or kind of stuff you operate on?
I don't think it's the number of customers. I think it's more like the number of entities you have in your data model. At one point, when your data model grows too big, then you need. If you just have a single data model with 3 entities, maybe you don't need GraphQL. There's still the point where Casper made about that. Okay, on the front end side, you might be able to get the results quicker if you can do a very tailored query instead of having to call individual REST services.
And you only get the data you need in the front end. That's
so for the performance
big
part of
advantage of it.
It makes sense.
Yeah, and if you need to call one API to get some data, and then there's a lot of IDs for the rest of the data, because if you have an actual RESTful API, you will hit something where GraphQL is nicer to use in the front end pretty quickly. At least I would think so, because you would easily get, now I need the images, then I need to put this, and now I need to get the people. Now I need to do another call for that. So if you just have one small card where I need to show 4 things, and that is actual RESTful, where each 4 of those are individual requests with IDs. If you're doing REST where you just give the data that they need in the first call, then it's probably fine for a long time.
Yes.
Yep. Let's have a 10-minute break. There's cake. So today we also wanted to have a small workshop. So that means you guys get to write some code and get the feel of stitching things together. And instead of showing our insane code, the 70 big graphs, and trying to get you to do anything in there, we decided we're going to try to get a Star Wars character's favorite Pokemon deck. So that means we need a full graph for Star Wars, and we want one for Pokemons. And in case you don't know, it's already available. On GitHub, there's already a Star Wars API. Casper showed you that earlier today, right? That was the REST API. This is the GraphQL representation for that. There is complete type definitions, so it's just go nuts on merging things together. The same goes with our Pokemon. So we have a Pokemon API that is available up here. Don't worry, you don't have to click those links. I'll guide us through it. But first off, we need an introduction to something called type GraphQL. So we've decided that this workshop will be in TypeScript. So you need the NPM and GitHub access. And then we have a GitHub repo that you're just going to clone, and then NPM install, and then we can run from there. And we will go to this one. Exactly. We set up a small project here called GL, Stitching Playground. And it's actually just a simple server, creating a server here and pointing to Yoga. GraphQL Yoga is another platform like Apollo, so you can run your GraphQL on a server. Very easy. So you run it on port 4000. It then says, give me the Supergraphs schema when we go to that. We can see that for the very simple setup here, we have an ice cream schema and a Star Wars schema. And just to understand what the Star Wars schema does, we can drill into that and see that it's actually just making a remote executor on this URL. And then says it's loading the schema, which we've already committed. So you already have a repo where all the typings, the schema definition is already committed here. And like Mads says, there's always a query in the root, and then you have all the fields that you can play with. This is not easy to get an overview of, right? So we also built in a small utility, and you can read that in the package.json here. So besides the start, there's a show. So if I go to this and say I want to show ice cream, let me just do the Star Wars first. When I show the Star Wars, it will open up a browser and it will highlight exactly how this schema looks. Now, this schema has a lot of root queries, but if we can zoom in here, we can see that it has films and all films, person and all people. And then there's this interesting line here. And the reason why that is there's actually, right now we've skipped something called the relay spec. If we try to show that, it becomes almost unbearable to read. But if we zoom in and try to understand what is actually going on here, there's a people connection. And that people connection is right here. And it is all about pagination. On the people entity, or the all people's connection, you can ask for page information. Am I on the first page or last page? What's the cursor? How many are there in total? What's the edges? And an edge is a standard for defining the node, which in this case is a person, and then a cursor. The cursor is whatever the backend needs in order to point to this again. So you should see this as a paginated list. It's called the relay spec, and it's used heavily in GraphQL. The reason for that is you never really want to expose any endpoint that just returns the full list of something you don't know the size of. You always want pagination because you want to be able to upfront calculate what is the cost of this query. When you are talking about REST APIs, you know for certain, when I ask for this, the contract is I have to return this. And then you know the price of that. But in GraphQL, you can build whatever query you want, and it can be extremely long this way, and it can also be very wide because it's a graph. So you can actually have a book that points to an author, that points to a co-author, that points to a book, and then you could potentially create a query that just goes forever because it's a graph. So you need to make sure that whatever you come up with, there has to be a price. We'll talk a little bit later. Query complexity is called, on how to make sure that you cannot build, because we're building a public GraphQL, so we want to make sure no one can mess around and create something that will tear down our platform. So we need some either this way or a combination. And making sure there's pagination, whether you obey to the relay spec or if you use something else, it doesn't really matter. You just need to make sure that up front you're saying, I need 10 of those. Then you can calculate it. Oh, there's a price for the 10, so we can know the size of this query. So I'll just hide that again because this is so much easier to understand. Because all you need to understand is that there is all people, and it's pointing to a person, and the person looks like this. And if we zoom in on the person here, we can see that on the person we don't know what their favorite ice cream is. So that's what we built. From the beginning here, you will be able to also show the ice cream graph, and this is where the type GraphQL comes in, because the Star Wars part, we're just pointing to an existing graph that's online already, so you don't need to do anything there. But for the ice cream, we actually implemented that up front here. So when we look at the model, we can see that we're just talking about a person with an ID, and it has a favorite ice cream, which is just a string. When we say it's nullable, that means that it could change going forward, so maybe it's not defined yet. When we look at the resolvers returns a query called person, and it is creating a stitch person function here. And then it takes an argument, and all these decorators, they are here to say all this TypeScript way that we're looking at can be changed into the schema definition. So it's a mapping from from TypeScript to GraphQL. Does that make sense? Somewhat. Yeah. It then has this stitch persons function here, and if we call the show ice cream just to represent that, we can see that it's the same as saying we have a subgraph where there's a query called stitch person that is able to return a person, but the person is all about an ID and a favorite ice cream. So this is talking about a person's ice cream, has nothing to do necessarily with Star Wars, right? But we made sure that there's a stitch person function here that can take in an ID, and that ID comes from the Star Wars graph. So here I've just hard-coded. Of course, you would need a backend or some other implementation than this, right? But at least we can show the idea here. So I already showed you the subgraph of the Star Wars and the subgraph of the ice cream. And now we're going to show you the Supergraph, which was over here. So this is the same as combining everything in one go. And you can see that the person, which is right here, has a favorite ice cream stitched in. The reason why it has that is the last file we didn't look at yet. Over here, in the ice cream folder, there's a schema. And this schema says whenever you are merging in this schema configuration, you need to merge the person, and you can call the stitch function, and you can take the ID and pass in as arguments to that function. So this is the magic that means that the stitching will actually be handled behind the scenes. So the folder structure right here is there's a server, and it has an ice cream, Star Wars, and Supergraph. When they look at the Supergraph, it is merely just awaiting these promises and saying, I need to fetch the ice cream, I need to fetch the Star Wars, and then I need to stitch those schemas together. And here we're using GraphQL tools, stitching, part of the, what are they called? The Guild. They provide a huge handful of tools to make it easy to work with GraphQL. So they are really important to look up. So when I run the npm start here, I have a server running, and now we can try to play around using it as a client. So right now we've just shown, okay, we have a subgraph for ice cream, we have a subgraph for Star Wars, and we can combine it, but we haven't shown you how to use it from a front-end point of view. And this is what we talked about earlier. There's a very nice tool set for doing this, and it's called this Explorer mode, where you can easily build up your query. So I can just say, I want all people. Actually, I don't want all, I just want the first 10. Then I go to the edges, nodes, because I know that it's using the relay spec. And then I want the name and the favorite ice cream, because that's what we're stitching in. And then I can run it. And now we can see that we get Luke Skywalker with a Magnum, and all the others get a Cornetto. Make sense? That's their favorite ice cream. And if you look here, you can see that we've actually, no one can see from looking at this that we have two subgraphs down below. So it's very easy to hide the complexity down below, and then make sure that the front end can say, all right, I need to only show the name and the favorite ice cream. I don't need all the other film connections or gender or hair color or any of that. That might be a different view. So we can create the query and only ask for what we actually need here. And this, like I said, this 10 means that the query complexity can be calculated. So we can calculate that this will have a number. Yeah, we'll get back to that later. Did I miss anything out? No. It'll come. Now comes the task. Yeah. So it's a good question. So what we just showed you is a way to stitch things together, right? And we want you to write the code. So this is a repo where there is already something set up, so you have something to look at. So the idea here is to create more or less the same as we did with the ice cream I just showed you. Create a Pokemon subgraph. So you'll have a folder called Pokemon. In there you will expose the Pokemon subgraph. And then you need a Pokemon deck, because you need to build something yourself. This, as I said, we can grab online as well. So we'll just make a more or less a copy of the Star Wars, right? And make sure that this is now pointing to the Pokemon schema instead. That's one of the sub-schemas we create. The other one is the Pokemon deck. And the Pokemon deck is responsible for creating a person and linking that person to Pokemon. And then the stitcher has to work so that when you are getting the Pokemons, you can get the data that this API provides. And when you are asking for a person, this will be the entry point. You get all people, get the first 10, but from that you can get the person's Pokemon. And those Pokemons can be exposed using this API. So it's not a lot of code, but it's interesting and complex thing to solve. And of course, we are here to help. So the idea is now, There's a Wi-Fi account or access down here. There's the git clone. It's a long name. You should have chosen something slow. We learn, all right? And then you start from the top here and say, I'm going to add the remote Pokemon schema pile down here, and then play around with the show function for that. See if you can visualize the schema just to see that works. Then you're going to add a schema configuration to that Pokemon schema that we're going to use later on, because we need the Pokemon to be able to be stitched in. And then we'll start building the Pokemon deck. And this is why you need the type GraphQL, just like the ice cream. So you're going to look at the ice cream example, copy that, and make sure that we can build the Pokemon deck where it has a person that links to a Pokemon. Yeah? Did I leave anything out?
Did you commit Pokemon schema?
Yes, that was a good question. Did I commit the Pokemon schema? So under docs, when you check it out, there's actually a small README with some links to if you need that. And then there's a link to the Star Wars repo and the Pokemon's repo, Git repo. But I also committed the entire schema for the GraphQL for Pokemon, so you can easily copy that. Yeah. The remote URL is listed in here. I'll just make sure it's the right one.
Go back to the slides so they can fill in the very long name for the Git cluster.
Yes. So the idea is we have until we're done, someone said, right? And then we'll wrap up with the more advanced features on GraphQL. Thank you for participating in the workshop. It was nice to see if we can get some code written. It's always easier to try to grasp all the concepts when you're writing the code yourself, rather than just consuming all this information. So we have a couple of more things to put on top of this, more icing on the cake, really, because now you get the gist of it. But if you really want to consume a GraphQL API, it's nice that it's type safe and it's easy to understand. So the viewer you have, or the explorer you have right now, where you can just pick and choose to build your query, is really easy to understand. Hey, I'm just selecting these 5 properties. Then you have your query, and getting from that to something that's type safe in your code is really important. And that's why we have this. Let me see if I can find it. Too many. All right, let's just do this. So this is the Guild, and they have so many tools available. And one of them is this code generator. If I can find it.
I think you need to go to the code. Is that part of GraphQL tools?
It is this one. So they have this code generator, live to build up some code for you. And they have chosen to show this live on their website. So you can see here, this is your schema, this is the operation, this is what the code generator needs, and this is the output. So let me just see if I can find a good, reasonable example. We use Apollo. Let me see if I can find it. There we go. We use Apollo hooks. So if you have this schema, it doesn't really matter how it looks. It's what the schema for the backend, right? Then you have this operation, which is the front end that wants to just get these few fields, the ID, username, and role. This query you can build in that Explorer, right? And then based on that Explorer, you want to generate some TypeScript and some React hooks. And what it does is it auto-generates this entire file for you, so you have typings for your specific query. So if you have a REST API, it's easy to understand that, hey, I can just generate the types up front because there's a one-to-one between what I ask for and what I get. But for GraphQL, any query is unique. So for the front end to consume this, it's important to understand that it's not just, hey, I'm getting just the name and then I'm standing with the full Pokemon object. No, you're standing with the Pokemon object with just that name on it, nothing else. And in order to consume that, it's nice that they have built these generators, so you can just say, yeah, I have this query, this operation, and I have these code gen tools, and then at the end down here, I get a function where this is the example how to use it. So you will see that all I have to do is call this hook in React. If React, this is a simple hook that takes some variables, and it's the user ID, and you can see that's also what I'm passing in. That's the ID in order to find the user, and back I get the data, the loading, and the error. So I can show a spinner while it's loading, I can get the error, or I can show an error message if it actually fails. So this is very easy to consume, and it has type safety built in. So when you're standing with data, it has data dot and then the structure, right? So you're getting the user and the user fields ID, username, and role. We don't really have the typings here, right? Because that's coming over from the schema. So we know that the username, it says right over there, it's a string. There's an exclamation mark, that means it is defined. If there's no exclamation mark, it means it's nullable. That's the definition language over there. So instead of the question mark or that we used in TypeScript, that's the way you do it over there. And here you can also get code generators for Angular or for Java or any other tool out there. And I highly recommend that you look into this from the client side so you get type safety up front. You can also do your own typings, but it will be one-offs every time you do a query. And then another pro tip, if you are doing NX or any monorepo, try not to push everything into the same library of these generated files. Remember, this query is meant for this specific UI up here. So if you're building everything, all the queries into one big chunk, that means that every time you add or change any chunk, the entire code base will have to rebuild. So it's always nice to keep the queries close to the code. That also means it's easier to maintain because, okay, where is this query used? You can easily find it in the code base. If you have a monorepo, just search and replace if you need to. Yes? And then over to Mads. Did I do it right? Yeah.
Yes. Just to wrap up, some pointers to some more advanced stuff. One thing we haven't talked about yet is directives. They're basically like annotations you have in Java or other languages. You can put them on different parts of your schema, and then you can have tools or you can have custom code that reacts to it and does something special with it. I just took this example we have from our schema where we have a custom field query. You can give it some input parameters, and there's a complexity and there's a preview. And the complexity directive, as Mikkel already talked about, is basically to protect against malicious queries. So in this case, if I query for all my users, I want to get all the groups they're in, and for all those groups, I want to get all the users in that group, and all the groups of those users, and yeah, so on and so on. You can see that explodes pretty quickly. But we are using this library called GraphQL Query Complexity, different libraries, and they have slightly different directives. It's not part of the standard, so it's per library it's defined. But this library has a value, which is like the base complexity you can put on a field. So you could put on a users that the base cost for this is 10 something, and then you can put on multipliers. So in this example, that's not a very good example, because usually for a good query, you will also always require to have a limit or a page size. So you might ask for the first 20 users, and then you put a multiplier on that says that the multiplier is this parameter that you're passing in. Yeah, and this plugin, when you annotate your graph with this, you can ask the plugin to calculate the cost of, or estimated cost of a query, and then you can just define a rule that says I don't want something that's more complex than 100 points. How you do it, it's really up to implementation. There's a very nice article by Shopify where they detail a lot about how they are doing it. Then the preview directive is something we've implemented ourselves, inspired by GitHub. They have something similar. The idea is that we're building a public GraphQL, and the moment we put something out there, if somebody starts using it, it's difficult for us to change it. But we still want to do rapid prototyping and maybe build a small POC, and maybe we are working together with an external company and say, hey, let's build this POC together. So we need to put stuff into the public schema that is not done yet. And what we then do is that we add this preview directive, give it a code name, and then if we look at the documentation, we'll write a message in the documentation that's actually automatically added when you put on this preview directive that says, hey, this is a preview feature. To indicate you know that this is a preview, you need to pass a special header to preview with this value. So basically, that's our way of saying, okay, now the developer has passed in this header, so he knows he read this message. It is implemented by a function called map schema in GraphQL tools. You basically take your schema and you pass it into map schema, and then you have the possibility to go over your schema and change it. In this case, we are adding extra description, and we are also adding a resolver that checks that you have this special header. If you don't add that header, you get an error like this. And here you can actually see this we talked about previously with the partial errors. So in this case, you get an error, but this is also successful because it actually returns an asset with a type and a brand and a name. But you can see down here the custom fields is null. And then if you look at the errors, you can see, oh yeah, I needed to add this geo preview, and it gives you the path that says the asset custom fields. And this is also a reason why it's important to put nullable on all fields that you expect that could throw an error. Because if we had said that, oh, custom fields is always there, it's never null, then this error couldn't have been returned because we couldn't have returned a valid object down here. And then we needed to go one level up and then return a null asset instead, for example. Or even further up and return no data at all. Because we marked it nullable, the client will expect a null in some cases, and you can code a UI that will show it and maybe do a small toast that says, hey, unable to load custom fields. Yes, finally, there's something called schema stitching directives. And now you've tried to in code write a schema configuration where you had this merge, Pokemon, and field name and all that stuff. You can actually do that with directives as well. It's a little bit about taste, but there's also little small changes or small differences in functionality. This doesn't cover all the cases you can do in code, but it covers a lot of them. And the power of this is that now you can actually move it to the subschema alone. You don't need to have extra configuration. So let's say in this case, if you have a remote schema, you can put in directives in the remote schema directly in your service, and then the router will just read that, and you don't need to add any extra configuration at the router level. How are we on time? Yes, we can touch on our public GraphQL as well. As mentioned, we are on this journey to create this extendable platform, and we have. You cannot see it. Go away, Zoom. How do I get Zoom away? Click more.
3 more, and then hide floating meeting content.
Go away, stupid Zoom. I'm not a fan of Zoom. So this is our private schema that we started out with. It's 70 subgraph that ends up with this massive thing. We are taking one subgraph at a time and making sure that we can expose it publicly, and then we're creating a public schema. So right now we have a long way to go, but it's very manageable because we have all these subgraphs, so we can just pick one and then focus on that one and then get it done. So we don't need to attack this beast head on. We can just take it one piece at a time. Then I promised to talk about a version. There's this tool called Hive GraphQL. It is a tool. It's basically a schema registry with some extra functionality. So it means that you can push your schemas to Hive and then from your subgraph, and then your router will be able to hook it up to that one and pull down schemas. I think there was someone that asked about if you could do a dynamic deployment. You could do something with that with Hive. Hive also supports schema stitching directives, so it can actually validate the schema you're coming with. Does this actually break anything, or is it still valid? It also offers field level user statistics. So in this case, I just took a screen dump from, and you can see the type asset, and you can see the ID was requested 14,000 times, and the share transfer was requested 0 times. So using this, you can actually more easily evolve your schema, because you can go here and see, so how many are actually using this field I want to change. The unique thing about GraphQL is that the client always tells you what it wants. So it lists directly, I need these 5 fields. And if then something like Hive, the Apollo Studio can also do something similar, can tell you, okay, so there's actually no one requesting this field, then you can more easily evolve your schema. Yes. And finally, we come from a world where we have all our subgraphs written in type GraphQL, but we are moving towards having it written in Java instead. We see a lot of benefits from it, because first of all, the performance of Java is better than Node because it's multi-threaded. We have some issues with some of these subgraphs blocking, and if we can offload that to the Java backend, then that's nicer. But more importantly, it enables the Java services to move more quickly. Because right now, if I do a change down here, then I have to, maybe I can do it myself, maybe I need to ask someone else who can code TypeScript to go up here, add the new field or whatever I'm changing, and then it gets exposed in there. And then the front end can update. So that's a long process whenever we are building new features. By eliminating this mapping layer, then it becomes more direct. Yes. And a little bit about our GraphQL Java setup. We are running schema first. So what you try today, you have with type GraphQL is code first. So you define your schema by code. We are trying schema first because we want to have a nice separation layer or contract layer between front end and back end. And with the schema defined, you can sit down with the front end, you can talk about the schema, you can define it. The front end can go submit the code in the front-end code, generate mocks for it, and start coding based on the mocks. The backend can go and implement it in Java, and when they meet, the types align. We're using Spring for GraphQL. It's a rather new Spring project started, but it fits with our existing Spring stack, so that was why we chose that one. And then we're using a code generator plugin that takes the schema and then generates, first of all, Java objects for all the object types, but also Java interfaces for the resolvers. So you can basically just start implementing all the interfaces, and when you're done implementing the interface, then you know you're done. Yes, I think that was it.